Well, a continuation of lesson 5.2 is discussing linear factors and zeros. By the time we're finished with this lesson, you're going to be able to analyze the factored form of a polynomial and identify relative maximums and minimums. So first of all, I want you to pause the video and answer these two questions and then come back and check your answer. This one was fairly easy, wasn't it? 2, 2, and negative 1. Now suppose someone listed the zeros as 2 and negative 1. Why might someone think this is a quadratic function? Well, it says the answers may vary, but we know it has two zeros, so we've got x to the second power at least, so that could possibly be a quadratic function, couldn't it? Multiple zero is a repeated zero. Multiplicity is the number of times that a specific zero occurs. Let's look and see what this means. What are the zeros of x to the fifth minus 6x to the fourth plus 9x to the third? What are their multiplicities? And how does the graph behave at these zeros? So first of all, looking at this function, we'll factor out the greatest common factor. X to the third, that leaves x squared minus 6x plus 9. We're going to go ahead and factor this as x minus 3 squared. So we can set x to the third up to 0, or using the zero product property, we'll end up with x is equal to 0. And this will be x minus 3, add 3 to both sides, so our zeros are 0 and 3. Now because this is x to the third, 0 has a multiplicity of 3. Since this is to the second power, the 3 has a multiplicity of 2. See how that works? We don't have to go x minus 3 times x minus 3. We can just say that 3 has a multiplicity of 2. And the graph looks like a parabola at x equals 3, and it's close to a linear at x equals 0. So put this in your graphing calculator and take a look at it and see if you agree with that. So you can pause the video for a moment and look at that function. And then the next key concept we have for today, relative maximum is the greatest y value of the points in a region of a graph, and the relative minimum, the least y value among nearby points on a graph. So we have looked at that before. What are the relative maximum and minimum of this function? And so this has been graphed for you. What I would do would be put this in my graphing calculator, and then once it's graphed, I would go second and calculate. First of all, let's look at the maximum. So I'd enter a 4 for maximum, and the maximum is this part to the right. So I'd move my spider about right in here and enter. Then I'd move my spider over to somewhere in here and enter, and then hit enter again to tell it to guess. You will notice that when x is 2.15, y is at 12.3168 or 12.32. Now we also have to locate this minimum. So again, we're going to go back and second calc. This time we're going to choose 3 for minimum. Now I'd put my spider somewhere over in here to the left of my minimum and enter. Then move your spider over somewhere over in here so it's to the right of your minimum. And then hit enter again for guess, and you'll find that it's at a negative 0.15 and y is negative 12.31681 or negative 12.32. Okay, you're ready to begin working on your assignment for today.